Are temperatures in your city rising every summer? Is your home getting hotter every year? Are your electricity bills soaring? Do you feel air conditioners don't cool well enough? Do you believe global warming is a fact? If your answer is yes to one or more of these questions, it is time you insulate your home. Let us together explore some facts on thermal insulation and understand how to insulate our homes. What are the exterior ambient temperatures and interior room temperatures at different times of the day? Let us assume a home in a hot and humid zone, without air conditioners. If the morning ambient temperature is around 30 degrees, interior room temperatures are about 3 to 4 degrees lower at 26 degrees. By mid-morning ambient temperatures rise to around 34 degrees while room temperatures are around 30 degrees. Post-noon ambient temperatures soar to 38 or 40 degrees and interior room temperatures to 34 degrees. And by end-of-day temperatures fall by about 4 degrees to 34 and 30 degrees. A good thermal insulation could bring the interior room temperatures down by 8 to 10 degrees, eliminating the need for air conditioners. If you still use air conditioners, the cooling cycle gets extended as room remains cool longer, thereby saving on electricity bills. Let us explore how. Let us first understand how buildings get heated. Radiation from the sun falls on the roof and walls of your home and also heats up the ground surrounding the building. A part of the radiation gets reflected back, this is called solar reflectance. A part is absorbed by the surface and later emitted out, this is called surface emissivity. Rest of the radiation gets absorbed by the building and transferred to the interior. This is called conduction. 25% of conduction in any building is through the roof, 35% is through the walls, 25% is through openings like doors and windows, and 15% conduction is through the floor. There is also an air film circulating inside and around the building both on interior and exterior, which is called convection. All these factors need to be considered while designing thermal insulation of your homes. Let us now understand some common terminology used in designing thermal insulation. First is solar reflective index. This is a measure of solar reflectance or emissivity of material used in construction. Higher the value, better the reflective property. We have already discussed terminology like radiation, conduction, reflectance and emissivity. SRI ranges from 0 to 100. Standard black is rated 0, while standard white is rated 100. A white surface reflects 80% of the radiation. Of the balance 20%, 15% is absorbed by surface and later emitted back, while 5% gets conducted into the building. Hence, a white surface is excellent for solar reflectance. On the other hand, a black surface reflects only 5% of the radiation. Of the balance 95%, 75% is absorbed by the surface and emitted back, while 20% gets conducted into the building. SRI of solar reflective coatings are higher than 110, as they have excellent reflectance and high emissivity. A good solar reflective coating can reduce interior temperatures by 5 to 6 degrees. Next factor is K value. It is a measure of thermal conductivity of a material. Lower the value, better the insulation. Assume a 1 square meter surface area of material, which is 1 meter thick, with a temperature difference of 1 Kelvin between the two faces. The amount of heat transferred through the material in 1 hour is the K value. K value is measured in watts per meter Kelvin. K value is also called lambda. Next is the R value. It is a measure of resistance to heat flow through a given thickness of a material. Higher the value, better the insulation. R value is calculated by dividing thickness of material by the K value. Unit of R value is m square K by W. Next is the U value. It is the measure of heat loss through a system, rather than a homogeneous material. Lower the U value of the system, better the insulation. U value takes into consideration the convection factor too. For example, consider a block wall system, with gypsum board cladding on inside, thermal insulation with foam, and brick cladding on the exterior. The sum of R value of interior air film, plus the R value of the 4 components of the system, plus the R value of the exterior air film, is the total R value of the system. U value is the inverse of the R value of the system, and is measured in units of watts per square meter Kelvin. Having understood the definitions of K value, R value and U value, we will now understand the norms governing thermal insulation design. These are norms set by the Bureau of Energy Efficiency, and in line with ASHRAE guidelines for insulation. The standard R value to be considered while designing, for exterior air film, will be 0.044. For interior ceiling and wall, it will be 0.16 and 0.12 respectively. While designing a good thermal insulation system, we can either consider U value of system, or R value of system. The maximum U factor for a good roof insulation should not exceed 0.41. And the maximum U factor for a good wall insulation should not exceed 0.44, as per the guidelines set. All our subsequent discussions will be basis these values. Having understood the factors and norms for thermal insulation, let us explore K values and densities of some commonly used insulation materials and building materials. Commonly used insulation materials with low K values are expanded polystyrene, extruded polystyrene, glass wool, mineral wool, polyisocyanurate insulation, polyurethane foam, and perlite. Lightweight foam concrete can also be used as a secondary thermal insulation on roofs. K values and densities of some of the commonly used building materials are listed in this slide. We would be using these values for design of our systems subsequently. Having discussed some commonly used insulation materials, we would now like to brief you on our range of products and systems recommended for thermal insulation. First in line is Momentum Insulation Plaster, imported from Turkey. Momentum Insulation Plaster FN25, a lightweight, glass bead-based, polymer-modified, fiber-reinforced, heat insulation plaster for interiors and exterior surfaces. 6 key features include excellent thermal insulation, good sound insulation, Class A1 fire insulation, low density and lightweight, water resistance, and eco-friendliness. Some of the key parameters of the product are listed in table. K value of Momentum is 0.052 and density 450 kg per cubic meter. The following 3-minute video will provide more information on Momentum Plaster.
Momentum FN25 and FN50 ecological thermal insulating plasters save money and adds a quite different dimension to your indoor and outdoor space by providing the thermal insulation, sound insulation, and waterproofing in the buildings via the right dynamics. Momentum ecological thermal insulating plasters, which are manufactured from Class 1A fireproof material that has low heat conductivity factor, provide to save 50% of heating cost by protecting the buildings from the factors such as rain, snow, and sun. Momentum thermal insulating plasters are water vapor permeable and resistant to moisture and acid rains. So they definitely prevent mold, fungus, humidity, and moisture formation. 99% of Momentum thermal insulating plasters is composed of inorganic products and 1A class fireproof materials. Their main distinctive characteristic is to protect the indoor and outdoor of the buildings by conserving the heat thanks to the hollow structure of the expanded glass stuffing beads used in the plasters. As it has seen, Momentum ecological thermal insulating plasters do not allow the thermal conduction from one side to the other. Momentum ecological thermal insulating plasters provide outstanding sound insulation thanks to the hollow structure of the extended glass stuffing beads used in the plasters. In this way, you can have a more peaceful life or practice your noisy hobbies freely in your house. Another remarkable feature of Momentum FN thermal insulating plasters are their air permeability and breathable structure. Momentum provides air circulation by protecting your buildings against high humidity and mold. Due to their structure, Momentum thermal insulating plasters are lighter around 70% than the standard cement-based materials. Momentum thermal insulating plasters, which compose of an easy-to-use, light and high-quality material, protect the surface of the structures while reducing the static load in the buildings. Momentum Ecological Thermal Insulating Plasters, which are manufactured from Class 1A non-combustible materials, have high resistance against possible fires in the buildings. It prevents fire spread to neighboring buildings and other parts of the building owing to low thermal conductivity value and due to high temperature protection. Another feature of Momentum Ecological Thermal Insulating Plasters have an easy preparation and application. A whole bag of Momentum FN25, FN50 is poured into the container for the mixture. Then 14.5 to 15.5 liter of water is added to the container and it's mixed by using the mixer for 6 to 8 minutes. The prepared mixture can be applied directly to the brick or an equivalent surface with the trowel or machine. Momentum FN25 and FN50 ecological thermal insulating plasters are more affordable products when compared to other thermal insulation methods. It can be applied to the interior and exterior walls of the buildings thanks to its texture, surface, and ease of use. As the best reliable friend of your buildings, Momentum will save water.
Our next product is a cast-in situ foam concrete. Densities achievable are from 300 kilograms to 1,000 kilograms per cubic meter. Foam concrete is good for thermal insulation and is fireproof. GEC has capability of producing and laying up to 100 cubic meters per day. Please watch the following 2-minute video for a better understanding of the product and service. Lightweight foam concrete. A cast-in situ foam concrete with density ranging from 350 to 1,000 kilograms per cubic meter. Foam concrete can be used for filling sunken slabs, filling large areas requiring to be leveled, providing slopes on roof slabs or podiums, which also serves as secondary thermal insulation, or for casting lightweight partition walls. GEC Private Limited owns 3 sets of foam concrete equipment. 2 sets are smaller equipment producing about 1 cubic meter per session and 40 to 50 cubic meters per day. With a pumping capacity of up to 50 to 60 meters height and density range between 300 to 550 kilograms per cubic meter. The equipment can only mix and pump cement, foam and water. We are currently demonstrating the larger equipment we own. This equipment consists of a mixing machine with a capacity of up to 2 cubic meters in one session, a foam generator which generates thick foam required to produce foam concrete, and a heavy-duty pump which can pump up to a height of 200 meters. The mix can include cement, sand, water and foam. The complete set of equipments can produce up to 100 cubic meters of foam concrete per day. The foam generator generates foam using a mix of foaming agent from aerosol or phosrock. This foam is pumped in calibrated proportions into the mixing machine. Cement and sand is filled into the mixing machine manually. The calibrated quantity of water is released into the mixing machine by the pump fitted to the machine. The mix of cement, sand, foam and water is blended together to form a uniform and free-flowing foam concrete. The produced foam concrete is filled in a large collection tank from which it is pumped up by the heavy-duty slurry pump through a high-pressure flexible hose pipe. The foam concrete is filled in layers of 5 to 6 inches at a time and leveled using a rubber squeegee. For larger sunken slabs, it is preferable to allow the first layer to dry and settle prior to the next fill. GEC can complete filling of large areas in short time using this technology. Please feel free to call us or email us with your requirements of foam concrete. The last product in our range for thermal insulation is a solar reflective coating. This is a pure acrylic coating with ceramic microspheres. We have a choice of 2 products, RD Thermoflex from Belgium, and APOC A247 from USA. The coatings have SRI greater than 100. They reflect IR rays and keep the roof cool. They have excellent weatherability, are easy to clean with dirt pickup resistance. They can be sprayed onto a metal or concrete surface as in following video. Ideal for use over thermal insulation plaster to improve overall thermal insulation properties. We will now discuss thermal insulation specifications for roof slab and for wall. There are multiple options and possibilities, and specifications may vary depending on location, size and type of roof, usage planned on roof, type of finish planned on wall, etc. For understanding the concept, We are discussing one typical scenario each for roof and wall. Our recommendation for a typical roof slab would involve a waterproof primer followed by a tried and tested waterproof coating. This will be protected by a geotextile membrane, followed by providing slopes with lightweight foam concrete for drainage of water. Over the foam concrete, a 50 mm thick layer of Momentum Insulation Plaster will be laid, with control joints both ways, to prevent cracking. Finally, 2 coats of solar reflective coating will be applied over the Momentum Insulation Plaster. For large spans, the solar reflective coating will be reinforced with a mesh. In the attached table we have calculated the R values of various components of the system. We have also included alternatives like PU foam insulation, concrete screed, cement plaster etc. to compare U values of different systems. R values of interior air film and exterior air film are as per norms. These will be common for all systems. R value is calculated by dividing thickness from K value of each component. Approximate costs have been considered for each component to arrive at system cost. RCC cost not considered as it is common for all systems. System 1 is the conventional system with cement plaster for interior ceiling, waterproof coating over slab, protection screed of 50 mm, followed by slopes with screed concrete. R value of system is 0.18 and U value 5.56. which is nowhere close to recommended standard of minimum 2.1 and maximum 0.41 respectively. System 2, we have considered cement plaster for interior ceiling, waterproof coating over slab, protection screed 50 mm, followed by 50 mm layer of PU foam insulation. Over the PU insulation, slopes will be provided with screed concrete. The system provides excellent thermal insulation. Only issue would be that the screed concrete does not bond to PU foam, hence acts like a floating slab and tends to develop cracks over time. R value of system is 2.35 and U value 0.43, which is very close to recommended standard. System 3 is as per our recommended cross-section on the left. R value of our recommended system is 2.47 and 0.41, which matches the recommended standards. This system is fully cementitious, hence ensures excellent bonding between layers. Protection screed over waterproof coating is not considered, since foam concrete is a pour and fill process, and does not damage coating. Our recommended system has a density of 1,200 kg per cubic meter, while System 2 has a density of 1942 and conventional system 2,240. Hence, our system reduces dead load on structure by almost 50%. Our recommended system costs slightly lesser than the PU foam insulation system, with better rating. For our wall systems comparison, we have considered 4 types of walls: solid block, AEC block, brickwork, and My1 concrete wall. For interior walls, we have compared Momentum 15 mm plaster versus 15 mm gypsum plaster. For the exterior, we have compared Momentum plaster with cement and sand plaster. Exterior wall specification includes a 25 mm layer of Momentum plaster, texture finished, followed by primer and 2 coats of emulsion paint. Interior wall specification includes a 15 mm layer of Momentum plaster, finished smooth, followed by a coat of primer and 2 coats of emulsion. For My1 concrete wall, we have recommended 15 mm layer of Momentum both on interior and exterior. Interior finished smooth and exterior texture finish. Both interior and exterior will be finished with a primer and 2 coats of paint. For the exterior, emulsion paint can be replaced with the solar reflective coating to enhance thermal insulation properties. For interiors, since Momentum is white cement based, it can be finished smooth with a steel trowel, and can be painted upon directly, saving putty costs. Momentum can also be left exposed, saving on full painting costs, if required. For exterior finish, Momentum plaster can be finished to a textured look with a textured trowel, hence saving cost of acrylic texture and scaffolding. We will now calculate R values of various wall systems discussed. R values of air films, on interior and exterior side of wall, will be as per norms. R values of the 4 types of walls can be worked out from the thickness and K value. AEC or aerated concrete blocks, are the best for thermal insulation. R values of exterior cement plaster, and Momentum plaster, for a thickness of 25 mm will be worked out. followed by our values for interior gypsum plaster, and Momentum plaster, for 15 mm thickness. An approximate cost for all components have also been included to compare system costs. As already discussed, for exterior, Momentum can be finished to look like texture, thus saving acrylic texture costs. And for interior, Momentum plaster can either be left exposed or directly painted upon. For my walls, we have considered costing basis 15 mm Momentum plaster on both sides. We will now calculate our values of various systems proposed, to arrive at ideal system, for a good thermal insulation. First would be the conventional system of concrete blocks, with exterior cement plaster, and interior gypsum plaster. Our value for this system is 0.39, as against the requirement of 2.1, as per norms. A similar calculation replacing concrete blocks with AEC blocks, yields an R value of 1.6, which is better but still lower than norm. We will now replace cement plaster and gypsum plaster with Momentum, for concrete blocks. This system has an R value of 1.06 against 2.1. Brick wall with Momentum plaster, yields an R value of 1.33. And my wall with Momentum plaster, yields an R value of 0.8. Our recommended system will include aerated blocks with Momentum plaster on both sides. This system provides a system R value of 2.26 and U value of 0.44, which are both as per norms. If we consider density of all systems, our recommended system will be 75% lighter than conventional system, reducing static load on structure. If we consider system costs, our recommended system will be approximately 100 Indian rupees additional per square meter, which is very nominal, considering the insulation benefits, and long-term cost saving in electricity bills. If required, this amount of 100 Indian rupees can also be offset by not painting interiors and leaving Momentum exposed. We have discussed thermal insulation for new buildings. We will now cover thermal insulation for existing buildings. For the terrace in existing buildings, there are two options. First would include providing a 40 to 50 mm layer of Momentum insulation screed, followed by 2 coats of solar reflective coating. This system will provide a temperature reduction of 7 to 8 degrees on interior side. Alternately, only 2 coats of solar reflective coating can be provided on the roof. This would provide a temperature reduction of 4 to 5 degrees on the interior side. For the walls, if possible, we would recommend providing a 20 mm layer of Momentum plaster, followed by 2 coats of solar reflective coating. If plastering is not possible, only 2 coats of solar reflective coating. Both roof and walls will first need to be primed with a bonding coat, prior to application of Momentum plaster. An ideal thermal insulation system would include insulation of roof, walls, openings and flooring. We have covered roof and walls. We would recommend riot glass to be chosen to cut heat entering through windows or a sun film to be fixed in existing buildings. Conduction through floor is only 15%, hence taking care of roof slab, walls and glass should ensure good thermal insulation. Post-insulation of your home, as per systems recommended by us, we expect an interior temperature drop by 8 to 10 degrees. Hence, morning temperatures would be around 18 degrees, mid-morning around 22 degrees, afternoon around 26 degrees and evening around 22 degrees. In cases of air-conditioned homes, you can expect huge savings in electricity bills, considering the temperature drops. We hope we have been able to provide you with reasonable information on thermal insulation. And also hope the presentation helps you plan insulation of your home better, in case you are constructing your new home. Or, helps you insulate your existing home to the extent possible, using our recommended products and solutions. We will keep exploring newer and better solutions to ensure we provide best-in-class solutions at all times. We sincerely hope you were satisfied with our range of products. We will be glad to support you with your requirements. If any of the products in the presentation excited you, please do the following. 1. Note down the name of the product or system name. 2. Call us or email us with the details. Send us pictures of your roof or walls requiring insulation. 3. Request us for a product catalog, or presentation hard copy, or soft copy, to shortlist the product. 4. Pick your choice of product or system, from the catalog or presentation. 5. Request us for a sample panel, or mock-up at site, only for larger requirements. We will also submit the budgetary costing for your requirement. 6. Sign off on the approved panel, or order confirmation, or release a formal purchase order, and we are all set to go. Thank you and look forward to your most valued business. Please note our contact details, and call us or email us for more information.